Hi all. Now we are just going to see a simple animation of a particular boiler. So whatever the boiler which is we are seeing is nothing but a pulverized type of boiler. So what happens is that this is nothing but we are giving the pulverizers which will help in giving air and fuel as a mixture from either end. So there will be a air preheater for heating that air before it is fired inside the boiler. So this coal and air which comes in contact at high pressure, so the coal will get burnt at the ignition temperature. And once it is getting ignited, then this heat will be transferring up. So the heat will move up then, and these are the tubes through which the water is flowing. And what happens to is that the water will get heated up. Once the water get heated up, what happens is that it will generate the steam, and this steam it can be used for driving uh, any kind of stuffs like it can run a steam turbine generator in order for generating the power, or it can be used for some heating purposes. So whatever you see in this blue color is nothing but the steam. The water is getting heated up and then it converts to steam, and then it moves to a place where it is being utilized. So this is an overall idea of how a boiler is working. So in the industrial building, the size of a boiler will be very large depending upon the type of use. Now we'll be discussing on the boiler feed water treatment. In order to produce quality steam from a boiler, the feed water quality is an important criteria. So the input to a boiler is nothing but the water. If the quality of water is bad, then the output, the steam quality will also be poor. So if the water quality is less, then the boiler efficiency also reduces and the life of the boiler also gets deteriorated. So this water, the feed water, it will be having a lot of contaminants will be there. And these contaminants, if it is not removed before giving into the boiler, then the components inside the water will behave differently. That is, at an elevated temperature and the pressure causes the water to behave differently. So that means the components in the feed water normally it is soluble in nature. But what happens is that at a higher temperature they will form a crystallized objects, and then it will get deposited inside the boiler. So once it is getting deposited inside the boiler, then the heat transfer inside the boiler decreases, and sometimes these crystallized materials will get taken away through the along with the steam. So once it is moving along with the steam, then it will get deposited inside the steam tubes, and also it will also affect the area in which we are using that particular steam. So therefore, the feed water treatment is a wider concern when considering the efficiency and quality of steam produced from the system. So deposit control of feed water is an important criteria. So these deposit in boilers may result from the hardness, contamination of the feed water, and corrosion products from the condensate and the feed water system. So we need to have a better control over the deposits inside the feed water. So these deposits can act as insulators and it will slow the heat transfer. So large amount of deposits throughout the boiler could reduce the heat transfer enough to reduce the boiler efficiency significantly. So therefore there are various kinds of impurities which are causing deposit inside the system. So like the salts of calcium and magnesium and also silica. So it is always important to treat the water before it is given to the boiler for producing steam. So basically we can say that the feed water treatment are of two types. One is known as the internal water treatment and the other one is known as the external water treatment. The internal water treatment is carried out by adding chemicals to the boiler in order to prevent the formation of the scale by converting the scale forming compounds to free flowing sludges. And these sludges can be removed by a process known as the blowdown. So depending upon the type of the water and the impurities present inside the system, the chemicals which is added to the feed water system will vary. So sodium carbonate, sodium aluminate, sodium phosphate, sodium sulfate. These are the types of chemicals which is used for treating the water or internal water treatment. Next one is known as the external water treatment. So the external water treatment is basically used to remove the suspended solid, dissolved solids, and dissolved gases. So there are various types of processes which are available for the external feed water treatment. So these kind of treatments are given before the water is being fed to the boiler. So the kind of treatment procedures are ion exchange, demineralization, reverse osmosis, and de-aeration. Next, we is the concept of boiler blowdown. So just imagine that you have your boiler and you have your water inside the boiler, which is being heated up in order to convert to steam. So because of, even though we are giving the internal water treatment and the external water treatment, there will be some kind of contaminants inside the water, and whatever that dissolved solids after generation of steam, it will remain inside the boiler itself. So these solids will get deposited inside the boiler, and if the amount or concentration of the solids which is getting deposited inside the boiler increases, then obviously the amount of steam generated reduces, the efficiency reduces, and the quality of the steam deteriorates. So it is always necessary to control the level of concentration of solids inside the boiler. So that is achieved by the process of blowing down, where a certain volume of water is blown off and is automatically replaced by the feed water. That means even though it is at a high temperature, we'll be removing some part of water from the boiler, so that whatever that solids, dissolved solids, which is getting deposited inside the boiler is being removed. So the process of removing such dissolved solids from the boiler is known as the blowdown process. So it is always necessary, the blowdown is necessary to protect the surface and the heat exchangers inside the boiler. The boiler blowdown, it can be classified basically into two. One is known as the intermittent blowdown, the other one is known as the continuous blowdown. In the intermittent blowdown, what we will be doing is that you will be having the boiler, and there will be a large diameter pipe which is connected to the bottom of the boiler. It will be provided with a valve mechanism. And what it does is that once the solids are getting deposited inside the boiler, this valve will get opened and it will be kept open for say 2 minutes. So in a shift or something, it will be operated one time or two times depending upon the size and type of the boiler. So what are the solids which is getting deposited inside the boiler? It will get removed through this particular pipe to the outside environment. And this is how we are doing the intermittent blowdown. And while doing the intermittent blowdown, basically what happens is that the water is getting removed from the system. So we have to replenish the boiler with the new water by providing the feed water to the system. And it is difficult to control the TDS levels because it is not depending upon any kind of study or something. The operator will come, he will open the valve, the dissolved solids get removed, and then he closes the valve. Next one is the continuous blowdown. So in the continuous blowdown, there is always a steady and constant dispatch of small stream of concentrated boiler water. That means you will be having the boiler, a small pipe will be there, which will be open always, so that there is always a removal of the solids which is getting settled at the bottom of the boiler and it is being removed. So it will be again at a high temperature and there is always a continuous supply. So there is an opportunity also to recover the heat from the blowdown process also. So this is figure is just showing that you are having n number of boilers which is connected, and there is a blowdown valve which is removing the solids, and it is taken over here, which is taken to a flash tank. So from that a heat exchanger is there in order to recover the heat from the water which is being removed from inside the boiler, and that heat can be used for some other purposes. So that is the concept of the continuous blowdown. So with the blowdown, it is possible to have a lower pre-treatment cost, that is the water treatment cost can be reduced, then it will also result in less makeup water consumption, because the quality of steam is getting improved, and therefore it requires less amount of makeup water. And since these solids are getting removed at a constant period of time, the maintenance required in the system is also less. It will also increase the life of the boiler and lower consumption of the treatment chemicals. Next, we are looking at the energy conservation opportunities in the case of a boiler system. The first one is a feed water preheating using economizer. So in the boiler, we will be giving the water will be given to the boiler. Normal water which we get from outside, it is at the normal temperature. But just imagine that there is because of the combustion gases, there is a lot of heat which is getting moved through the stack. That is the flue gases. And these flue gases will be at a higher temperature, maybe 200 degrees centigrade or 300 degrees centigrade. So that heat, rather than being lost to the environment, it can be used for heating the water which is given as the inlet. So it is a feed water preheating. So therefore, rather than giving the normal water temperature 30 degree, you may be giving the feed water at only 60 degrees centigrade. So therefore, the amount of work done in order to convert water to steam get reduced. So in terms, it is going to increase the boiler efficiency. Next one is combustion air preheat. So you will be giving air and fuel to the boiler system. So this air at normal temperature, it may be some 35 degree or 36 degrees centigrade, something like that. And it is also possible to increase the temperature of the air by utilizing the flue gases. So these flue gases can also be used for increasing the temperature of the air which is given to the inlet. So that will also increase the efficiency of the system. Next one is incomplete combustion. So you will be having the type of fuel, say in the case of coal. If the coal is not properly combustion does not happen, then the efficiency of the system will reduce. So along with the ash also the coal also get deposited. That means the combustion is inefficient. So that means an unburned carbon will come, and that will compress to a big losses will be there. So it is always required to control the combustion such that the complete combustion of the fuel happens inside the boiler system. Next is the excess air control. That is, the air is being fed along with the fuel. If the amount of air increases, that is, the excess quantity of air goes inside the system, it will also result in poor performance of the boiler. So it is always required to control the air. The last one is stack temperature. Stack is nothing but this one, that is the chimney. So if the stack temperature should be kept as low as possible, but there is again some constraints are there in order to reduce the stack temperature. If that is kept low, then the water vapor along with the gases will condense and it will still stick onto the walls. So the stack temperature has to be kept depending upon the type and size of the boiler which we are using. And if there is high temperature is available, that is about 200 degrees centigrade, then we can also think about recovering the heat from the stack. Thank you.